Okay, so here is the last big thing, which is going to kind of be a summation of a lot of the things we've done. The only thing that's not involved in this is really stoic, okay? But more importantly, what this is going to basically assess you on is that can you do science, okay? And by science, I mean science is a verb, okay? Science isn't like a topic. Science is a thought process. So what's going to happen is that, first off, that's on that lab sheet. Make sure you put your name on it, who I am, so in case these get lost, because they all look the same. Block 1, return date is going to be next Wednesday, okay? We'll just put Wednesday. You all know what that is. So here's what eventually will happen. So each of you are going to be given 3 vials like this. So this is like Keaton Crockett's, okay? So Keaton is number 1. Literally, what happened is that we had a whole spreadsheet, a computer, this randomly generated list of these possible combinations. And I just went through and I randomly assigned all of you a number, okay? So it went down alphabetically. So like Keaton, we just went down alphabetically, so Keaton's number 1. So Keaton's going to be given this vial, and it's going to be labeled 1A. So Keaton's task is to figure out what the cation is, what the anion is that make this up, okay? So then he's going to have another one, so here would be like 2A, 3A, or 1B, 1A, 1A, 1B, 1C. Okay, so that's when what he gets done, that's what he's going to have. So, but before you can do that, okay, and this is what I put more emphasis on the front end. The more work, the more effort you put in on the front end of this, the easier the identification is on the back end. So the whole idea of science is that you gather a body of evidence. So here's what's going to happen. So over here on page 4, okay? Over here on page 4, here's the heart and soul of this. So here's what's going to happen. These vials contain combinations of these cations and potentially hooked up with these anions. So for example, you could have lithium acetate, you could have lithium phosphate, you could have lithium sulfate, you could have lithium chloride, okay? So there's any number of possible combinations. You could have calcium acetate, calcium phosphate, calcium nitrate, okay? So the whole task of this is that you have to identify both the things that are there. You have to figure out what the cation is, and you have to figure out what the anion is, okay? Now, a large portion of this is what I said, and this is what I have to emphasize to you. When I did this lab, when we first developed it, I spent, you guys are going to have 5 days. I spent basically the first 3 days going through and testing what I knew. So what's going to happen when we get over there in the lab, you are going to have like containers, and it will say, this contains the lithium ion, okay? So if you can figure out how that lithium ion reacts in a flame test, how does it react with sulfuric acid? How does it react with these? So right here you have these reagents. We talked about reagents before. Reagents are what you add to make things happen. So if I take a lithium ion and I react that with ammonium hydroxide, okay, so you will have a known lithium ion. You will know, here's lithium. So if you can figure out how that reacts, then when I give you that unknown and you perform those tests, and then it's just like a match game. Oh, well, this is lithium because it does this. So over here on page 6, okay? Over here on page 6, what it does is that it lists the characteristics. Y'all kind of have a head start, because you're going to be told, oh, this is what's going to happen. So for example, if you have the aluminum ion, okay, there's no real characteristic flame color. Some of these, when you do the flame test, you get a distinctive color. Some of them, not so much, okay? forms ions, and it changes the pH of a solution. Okay, pH is referring to if something is acidic or basic. So pH is a measure of the concentration of hydronium ions. So if something is acidic, that means that it has more hydronium ions than hydroxide ions. If something is basic, it means it has more hydroxides than hydroniums. If it's neutral, the numbers are the same. You have the same concentrations. Okay? And we'll talk about, we're going to have what we call litmus paper. And litmus paper changes depending on something as an acid or a base. Okay? Forms precipitate with sodium hydroxide solutions, but don't blink twice. So what you want to be able to do, even though it says this, the whole key to this is that do you do the work on the front end? So what you want to do, well, this is what I did. I'll tell you exactly how I handled this lab. I went through and I said, okay, hey, here's something that I know what that aluminum does. I went through and said, okay, based upon this, what does that flame test look like? Even though it says it has no distinctive color, I still want to know what that looks like. I want to see what these reactions physically look like. So what's going to be the most important part for you to fill out is over here on page 10, okay? So this is what you want to spend the vast majority of your time filling out. Because if this is filled out thoroughly, if this is a very good working body of knowledge, then the unknown part becomes very simple. So, like for example, aluminum, okay, makes a colored solvent. So what you'll see is that some of these, like for example, this one, some of these have a distinctive color to it, okay? So, like this is Ethan's 15C, okay? So this is Ethan's salt. That's going to be his last one, okay? So that has a distinctive color to it. That has a distinctive color to it. There's some of these that, like this one, is kind of a pinkish color to it. So some of these have a distinctive color to it. So if you don't know what that color looks like, then when I give that to you, if I give this to Ethan, and he doesn't know which ones are potentially have a colored ion to them, he doesn't know what to do with it. So that's going to be part of it. Then you've got on all of these has a distinct odor, okay? And again, you all know how to do the WAF thing. The odor thing really isn't, it's like do this, okay? That most of them aren't, okay? Don't think that this is going to be like a cookie lab, like, oh yes, that has a nice bouquet. No, okay? Most of these don't have a distinctive odor. So, and that's going to be with that aluminum, okay? You're going to go up and you're going to find aluminum. Does it have a distinctive color? No. If it is, yes, what does that potential color look like? Is it green? Is it brown? Is it rose colored? Okay? What does it look like? Has a distinctive odor? Yes or no? Precipitates with the following ions. Now, let me give you a hint. One of the most important tests on a lot of these is does it form a precipitate? So for example, if you take aluminum, and here's the other thing, this will make sense once you watch the video. So let's say, for example, you think you might have aluminum. So to test for these, if they're going to make a precipitate, the first thing that you've got to do is that, for example, if you know you have aluminum, you can test for aluminum. So you're going to get a little bit of aluminum. You're going to put it into a test tube, okay? And again, you're going to have there's going to be a bottle that says this is aluminum, okay? So you're going to take a few granules of this aluminum, add some deionized water to it. Do not add tap water to these if you're testing for ions, because you all know that tap water contains a myriad of ions that are just going to contaminate your solution. So you're going to add some water to it, and you're going to make this thing into a solution, because you want these ions to move around. And that's another thing that you can test for. When you add that water, how easily does it dissolve? Some of these dissolve very rapidly, other ones, it takes a while. So if that's one of the things, not only you need to make an observation, is it soluble in water? And if it is soluble in water, does it dissolve very easily in water, or does it take a while? Okay? So let's say, for example, if you look on your solubility rules, okay, and this is one of the key things you got to be able to do, is your solubility, because you're going to have access to a wide variety of information. So you dissolve this, and this is the key. As soon as you add that water, now you have aluminum ions, okay? You have Al3+. You don't have solid aluminum, you have aluminum ions. We're not testing for the presence of aluminum like you have in a can. You're testing for the presence of aluminum ions. So if you take aluminum and you make hydroxide, okay? And you would make aluminum hydroxide, okay? So one of the things you want to ask yourself, look on your solubility rules. Is aluminum hydroxide soluble or insoluble? Okay, well, aluminum hydroxide is insoluble because most hydroxides are insoluble. There's very few of them that are. So you know you can make this precipitate of aluminum hydroxide. Okay, well, how are you going to get the hydroxides? Oh, we have a reagent bottle of sodium hydroxide. So here would be your step. You're going to take that, you're going to take a known bottle of aluminum over there. It's going to be on the center table. You're going to take a little bit of aluminum. You're going to put that into your test tube. You're going to add some water, dissolve that, get it to where it's soluble, make that observation. Hey, does it dissolve easily, or does it dissolve, or is it tough to get that aluminum ion to dissolve? Okay, got that bit of information. Then you're going to add that reagent of sodium hydroxide. Cool. Okay, I add sodium hydroxide. Then does it form a precipitate? What does that precipitate look like? Okay, is it a chunky white precipitate? Is it a brown precipitate? Is it what we call a gelatinous precipitate? It means it's very difficult to see, but it's there. Okay, doesn't make a lot of it, doesn't make a little of it. So those are the things that you want to quantify. Okay, so if you look on this reagent list, okay, so you've got ammonium hydroxide, okay? You've got sodium hydroxide. So there's actually a couple of different sources you can have for your hydroxide. Does ammonium hydroxide produce a different precipitate than if you react it with sodium hydroxide? Okay, I don't know. That's what you want to look at, okay? Let's say you think you might have, notice on here that you might have, on your anions, you might have chlorides. Okay, Cl1 minus. So if you look on your solubility rules, most chlorides are soluble. Okay, they are. Most chlorides are soluble, except for, what's the two exceptions that chlorides are soluble? Except for silver and lead. Oh, okay. So you're going to have, on the other side of the table, you're going to have the known anions. So you're going to, on one side of this is going to have all of your cations that you can test. On the other side, you're going to have all of your anions that you can test. You say, okay, hey, I'm going to grab some of that chloride. You're going to do the same thing. You're going to dissolve that in water, make it into the chloride ion. Then, what I would suggest then, you have silver nitrate. Because you know, if you add silver ions, you're going to get HgCl. So you know this should make a precipitate. Okay, you know this should make a precipitate. What does it look like? A lot of precipitate, a little bit of precipitate. So that's what I'm telling you. So as you go through this, on this page 10, so there's one page that becomes, this is going to become like your encyclopedia. This is going to be your reference page. The more information, the more detailed information you have here, the last step then becomes grading. It's like, oh, okay, you take this, so when you get this whole thing done, Keaton's going to come up and he says, hey, Burkham, I think I have a working body of knowledge. So I'm going to give him this. And what he's got to figure out is two things. What's the cation and what's the anion? Okay? Two things you've got to have figured out. Cation and the anion. So he's going to go through and he's going to do these tests. He's going to take a little bit of this, he's going to dissolve it in some water. Okay, hey, what does that look like when it dissolves in water? He might add, well, let me check for chloride. So he's going to add a little bit of silver nitrate to it. Does it form a precipitate or not? So what you'll see is that not only is it the positive test, but it's also what does it not do? So if you add silver nitrate and you don't get a precipitate, right away, I don't have to worry about the chlorides, okay? So that's what you have, if you follow this thought process, this is what you have to figure out. And so sometimes it isn't necessarily a positive test, it's an elimination of things that it can't be. So if I get this and it's a white powder, which most of them are, right away there are certain cations that it can't be. Because what you'll notice is that certain cations have a certain color to them. And if it's white, you can eliminate some of those cations because of the fact that they have a certain color. None of the anions have a distinctive color. Okay, they don't. So none of the anions have a distinctive color. Only some of the cations have a distinctive color. So you can use a color test for the cations, but you can't do any color tests for the anions because they're all going to look like white powders. Okay, but even within that powder, when you go through this and you begin to look at them, some of these powders are more granular. Okay, like sugar cubes, and some of them look like fine powder. So if I look at this one, like with what Ethan's going to have, when I look at this, those are some pretty big granules, okay? So if I'm Ethan, I'm going to say, wow, some pretty big granules, okay? But if I look at this one, which is also a green, this one is very much almost look like green flour. So just because you have a color, also pay attention to what does that texture look like. Is it a fine powder? Is it granular? What does that look like? So that's what I'm telling you. The more information you have here, the easier this process is going to be. So here's the big idea, okay? When you get done, okay, when you've got this whole body of knowledge filled out, and this is one of the things, you don't have to have like all of these, like flame, by the way, the flame colors, really, the flame color won't do any good on the anions. Flame tests only work with the cations. So down here where it says flame color, don't worry about the anions, that won't do you any good. The flame colors only works with cations. So that's one of the things, there are certain things that I would do right from the beginning. I would do the flame color test, okay? That's one of the first things I would do. I would get all of these and it'll show you in the video how you do a flame color test. Basically, you take a little bit of this stuff, you dissolve it in some water. We have nichrome loops. You take the nichrome loop, you put it in there, you put it in the flame, you get a color, okay? So the first test that I would do that flame color test, first thing I would do. I would precipitate with the following ions, okay? You have your solubility rules. Is there something you can use to make lithium form a precipitate? The answer to that is no, because it's a group 1 element. So you know lithium, sodium, potassium, none of those are going to form precipitates. So don't even bother trying to make those form precipitates because of the fact they can't, because they're group 1s. Then you get into the calcium all the way down to lead. Those will form precipitates. What I would do, if I were you all, personally, I would go through and I'd say, okay, what can I do to make calcium, barium, iron, nickel, whatever? What can I react those with to make them form a precipitate? Is it hydroxide? That's the common one, okay? Is it, what are those going to look like, okay? And if you do know it's going to form a precipitate, what does that look like when it reacts with the reagents? Is it a light precipitate? Is it a heavy precipitate? What's that going to look like? Down here, you know that, so like chloride, for example. Chloride is basically insoluble. Excuse me, chlorides are basically soluble except for silver and lead. So I'd go over there, I'd find the chloride known. I'd dissolve a little bit of that, I'd add some silver to it, boom, what does this look like? A lot of these anions, what they will do is they will change the pH. It will either make them acidic or it will make it basic, okay? That's one of the key things that I would focus on down here with these anions. What does it look like when those change the pH, okay? Does it make it acidic? Does it make it basic? Now, I'm going to tell you right now, here are the two that are really tough to distinguish. You have H2PO4 and HPO4. Those are tough to figure out, okay? Because they're subtle in how they change the pH, they're subtle in how they dissolve. So if there's ever two that you really want to try and figure out in terms of the difference, that's going to be those two, okay? Just telling you. The other ones are pretty obvious. They're going to do different things, but those, that's going to be tough to do. So you might make a little asterisk and go, okay, how do I differentiate between those? That's something that you need to work on. Okay, so we've got like about a 30-minute video. This is Mrs. Schertz. We have to show this to like all the Chem 1 classes so that everybody kind of starts with the same working body of knowledge. So we'll get that. There we go. Switch over to, oh, this is going to get complicated.
Because it's off super quick, or else it'll be like cloudy, and I don't know what to write then. She said the flame test is going to be the best one.
Why'd you wake up on the wrong side of the bed? You pooped in your Cheerios. You're serious.
And then he said, I think aluminum is equal to
Maybe it was 30. Stop! Get that off my desk. What?
Where's your spoon?
You just wish your nose was there.
Not like here's the thing, like how you just Google
How can you be so hard to hope for you?
yeah.
What's
I didn't know.
What is that?
What are you taking?
Bruh.
I barely
use those.
fit that too.
All right.
That makes me feel better about myself. I mean, I've had 87, so it's not too bad.
And today we are going to introduce our lab final. So you have
Yeah, I've had
one. And hopefully on the front of this, please put your name, my name, a block, and then your return date, folks. You don't need to fill that in yet. So this lab final was actually originally created by two teachers that I taught with at Millard South High School. So their names are listed on the bottom, and we have given them credit for letting us use this lab. And so what we're going to be doing is you're going to be getting one unknown at the end of class today. We'll have a total of 3 of these to do between now and the end of class next Thursday for us. So you basically get, today included, a total of 5 days on your lab final. So each one of these requires you to do some different tests and identify this unknown. So this is basically an ionic compound. So we have a cation and an anion. that are represented in here. So to see what your possible options are, let's take and kind of browse through this for just a second of our packet. So on page 2, notice it's got some general instructions that you can read and we'll look at here in a little bit. We also have some rules of lab conduct. So that would be something we look at on page 3. Then notice on the top of page 4, we have positive ions and negative ions. So this is a list of all possible cations that we could have. You have to have one cation and one anion. Okay? There could be any combination of these. And so you are running tests to figure out what ionic compound do you have. You'll have one cation and one anion. Down below here, it gives a list of reagents. And so what reagents are, is those are aqueous solutions that we have prepared ahead of time for you. And so right over here, in the trays that we're used to using for lab, you have a prepared group of reagents for you that we'll be using. And so along with that, there are 4 microspatulas, and then you will have access to a flame test wire that we will see also here in a little bit. What we're going to do today here in a minute, after we look at some beginning things, is we're going to actually go through preliminary tests, and we're going to do this unknown together. Okay? So what I want you to do right now is go back on this at this moment to page 2 and page 3, and I'm going to give you a couple of minutes to go ahead and scan through page 2 and page 3. No, leave it on.
I think this is. Hold on. This is so.
It's driving me crazy.
She was just sitting there reading with her mouth open, but not so.
I
You
know.
can access those at any time over here in the classroom area. A couple of other things that I want to keep in mind is if we are smelling something, make sure you're wafting, okay? Don't smell it directly.
Now it's back in
Also, as we are dealing with waste, there will be some different instructions throughout your packet that will tell you certain things need to be disposed of. So if it is precipitate waste that needs to go in the precipitate waste container, please access that in the fume hood. Okay, if you have questions about disposal, that is definitely a question that you can ask me. All right, so at this point, let's go ahead and go on, and let's look at page 5, which is the preliminary test, and we're actually going to run through some of those for our unknown. We are also going to be filling out our sample sheet, which is found at the very back. So notice the sheet right here that says results for unknown. Okay, we're going to be flipping back and forth here. We're going to be filling this out so you have an example to follow as you're doing this throughout next week. So the first thing we're going to do is an inspection test. So you're going to look at your unknown. You can open this up. You can waft a little bit. Don't pour it out into a weigh boat because you'll be wasting some of the material. And so as we look at the inspection for this,
And by the
we
way,
are going
what you
to write
get is
down some
what you get.
information for that. And so at this
Don't
point,
mix
you
it all
turn your
up.
packet to the page that has sample on it. I'm going to bring up one that is up here for me. I'm going to scroll up just a little bit. So you should have a sample sheet in your packet that looks just like this. And the first thing I have for my inspection test is that it is moist.
Some people hate that word, I know.
And pale violet. This sample sheet of this will be able to be found on Google Classroom later today, and it'll also be posted throughout the room in case you're having a hard time keeping up with some of that. So at this point, I'm looking for anything that would be a possible ion. Well, as I look through my information, so if I go to the cation section and I look at my ions, I'm looking to see, mine kind of has a pale violet, so I'm looking for anything that says it could potentially be a colored compound. And as I look at this, I notice that iron can be colored. I look at copper could be colored. And I also notice that nickel could be colored. And so I'm going to write over here, my possible ions could be copper.
So what she's looking at is that very last page in that packet.
And it could
That's what
possibly
you are going to
be
fill
iron.
out. You're going to fill out 3 of those. One for each cation, or one for each unknown that you
The
have.
reasoning it could be any of those 3 compounds is because they are colored.
So on that one, like most of these are just
All
going
right,
to be white.
so then we're going to
So
move
if
on
it
to our
was
second
white,
test,
then
which
you
is
would
going to
say,
be water
oh, here are the
solubility and
ones that it
litmus
could
test.
be
We will
because
add
it's
water to a
not,
small
because it
sample
doesn't
of the
have
unknown,
color.
about a fourth of spatula, and pay special attention to the amount of water needed, the color of the solution, and the acid-base properties of the solution. And so then it's going to give us some additional things that we're going to want to do with that. So at this point, I'm going to use some test tubes, and so each person will need 4 clean, dry test tubes. So this first one is you're going to add a small amount of your sample, about a fourth of a spatula, to that. So I'm going to take my spatula, I'm going to take a clean, dry test tube, and I'm going to grab about
And
a
clean
fourth of a
glassware is
spatula
your
full
friend on this lab.
of this. The most important thing is that you're keeping a consistent amount that you're putting in so that you have the same concentration each time. So at this point, my unknown is on the bottom, and now it says that we're going to add a drop of water, 1 drop at a time. We're going to add a total of 5 to 7 drops, but I want to see basically how quickly this dissolves. So 1, 2,
And again, if you don't have that
And I
body
can
of
see it really
knowledge, if
after
you
about
don't
3
know how it
drops,
dissolves,
that
that
has
test
dissolved,
does you
so
no good.
4, 5. And so at this point, I'm going to remain consistent here, and I've got 5 drops for my water solubility test. And so now at this point, I'm going to set this aside for a second and come back to this up here. And for my solubility test, I'm going to write that it dissolves quickly.
So at that point, then if you have that information, then you can go back and go, okay, which cations or anions dissolve quickly?
Okay, and at this point, folks, I don't really know, and I don't really have anything that's, I'm going to get information for on that component at the moment. So I'm going to leave that blank and probably come back to that after I have a little bit more information. Okay, the next thing I'm going to be doing is a pH test, and there are a couple of different ways you can do this. You can go ahead and use this and basically try it with pH paper, which we've used, red and blue litmus paper, or probably the thing that we have used most common is universal indicator. And so I'm going to go ahead and put a drop or 2 of universal indicator in there. Sometimes this can be tricky if you have a colored compound. Other times it's easy to tell, so you just have to decide which one you need to do. So I have now added a drop of universal indicator, and it is red, so we know that it is what? Acidic. Very good.
So you can
pH
either
test,
basically universal
observations,
indicator or
it
litmus
is
paper
acidic.
that does the same thing.
Okay, I also do not have any specific things for that right now. I do know acidic, I'm going to look for my pH chart. And if I'm looking at my pH chart, I know that it's very acidic. And so we probably have something around a pH 1 or 2. Possible ions, I still don't really know anything about that at the moment, so we're going to leave that blank at the moment. The next thing I'm going to have to do is a flame test. And so in order to do my flame test, I'm going to use a flame test loop. I can also use a wood splint, which I've used a couple different times. If you're doing a flame test loop, you have to potentially clean this first, and there are instructions for that over on the middle island. I've already cleaned this flame test loop.
Basically,
So,
you dip it in
at this
hydrochloric
point, I'm
acid,
going to just show
burn
you
it,
how to use
and
it,
then that
and
way
I'm
you
going to
burn
tell you
it
what the
off.
flame color is. We have done flame
Any
tests
other
before,
ions
hopefully you
are
still have
already
your
on
flame
it.
test lab results. If not, that's something you can also look up. So to get your flame test loop, this is a lot like blowing bubbles if you're using your loop. You need solution in that loop to be able to actually see the color. So you're going to pull this out, As long as there's solution in there, you're gonna put it in the flame, and we're gonna look for a flame test color. Now, this particular one has no flame color, and so we're gonna write that down. I would typically do this in a Bunsen burner, and it tells you how to do that. If you're having a hard time, can you also soak a wood splint in here, like we did in the actual flame test lab, and use that to burn? Absolutely. Okay, I'm gonna tell you, don't eliminate something based on a flame test, but some of you are gonna get some things that are very obvious. In fact, what would probably be a very obvious color that instantly would tell you what we had?
Green.
Green, and that would mean we had what?
Copper.
Copper. Okay, so we look at our flame test, and for this particular one, we have no flame color. And so possible ions at this point, well, we know that copper has a green flame test color, don't we? Okay, do we know anything about iron and nickel? Okay, so right now, look at your packet for those two ions and see, do either one of them have a flame test?
Iron is no characteristic flame color.
So iron has no characteristic flame color, and what about nickel? No, so could we still have iron and nickel?
Yes.
Yes, so my possible ions are still iron and nickel. But we have now eliminated copper. Okay? And the reasoning for this is no flame test. Okay, we've now on our preliminary test on page 5, we have completed through number 3. So we're now ready to go on to test number 4, which is dealing with dilute sulfuric acid. So we look at dilute sulfuric acid, and it says you will add half a spatula of your solid unknown to a dry test tube and add dilute sulfuric acid 1 drop at a time to the acid. Observe any reaction that might occur at room temperature.
So with this
do not
one-
add more than 5 drops of the acid. If no significant reaction occurs, gently.
This is one that's kind of unique with this dilute sulfuric acid test. Most of the other ones, you're gonna add water. Like if you're doing a precipitate test, you'll add the water, get it as an ion, then you'll add, like for example, if you're testing for the presence of silver chloride, you think you have chloride. Okay, you dissolve it, you add the silver nitrate, it doesn't get a form of precipitate of silver chloride. This one, this is one of the very few that you add this directly to the solid. Okay, you don't dilute it first. Okay, and all those instructions are in there, but when you're doing this dilute sulfuric acid test, you do this directly to the substance. You don't dilute it first. Most of these you dilute it. Like if you're doing a flame test, dilute it. And that's one of the things that she stressed that you really need to pay attention to. When you're doing flame tests or whatever, make sure that you're always adding kind of the same amount each time. Because if you add a lot of that solid and then you add 6 drops of water, versus if you add just a little bit and you add 6 drops of water, that's completely different molarities because of the concentration. So one of the things in your technique, when you're doing this, even when you're doing like the known ones, aluminum, get in your mind, hey, how much am I going to add each time? Because depending upon the concentrations, you get different amounts of precipitants. So that's why you want to make sure that you're consistently adding that same amount of solid to that test tube each time.
Heat in the burner flame. If nothing happens, heat the test tube more strongly, shaking it gently as you heat it so that it does not explode out the top. Do not boil, acid, so on and so forth. So we are going to now perform that test. So again, I need to go back to my unknown. I need to get some more spatula. And so the first one was 1/4 of a spatula. This is a half, so it's going to be a little bit more in my test tube. So I have a half a spatula. And it says you're going to add dilute sulfuric acid to this. I want you to put out to the side. Notice it says dilute sulfuric acid. Circle what molarity is that. What does it say on number 4 what molarity is for sulfuric acid?
6.
Alright, well, it will be right that. As I am looking very quickly to go grab that, because apparently I don't have it in your tub, I need you to go ahead and look and see and kind of read through the ions that are on pages 6, 7, 8, and 9. I'm gonna just scan through that a little bit. Okay, so we're going to add dilute sulfuric acid to our test tube of our unknown. And I am going to make sure I add 1 drop at a time. And I want to make sure that I don't add more than how many drops?
5.
1.
And you would observe how that stuff is reacting as you
Right,
add
so I
those
have now
drops.
added 5 drops of sulfuric acid. Mix that a little bit. And as I'm looking at that 5 moles of sulfuric acid, am I having any reaction? No. Okay? So I've had no reaction with that. And then at that point, I'm also going to go ahead and heat that up. So I'm going to get a Bunsen burner.
Now, when you're heating stuff up, make sure you do not point that test tube at anyone. As tempted as it might be.
Okay, I'm going to use my handy dandy test tube clamp. And when I do this, I want to heat it gently at first and make sure it's not, the end is pointed away from anyone. So gently, and as I'm heating that gently, nothing is happening. So I'm going to try heating it a little bit more strongly. And I still have no reaction going on with this, okay? At that point, remember this is a hot test tube, so do not put it back in your plastic rack. You can get out a trivet if you would like, and put it on your trivet.
And do not, well, she did. But don't put anything hot on those countertops, okay?
All right,
Don't
and so
do
now
it.
we have
And
to put
don't,
our
if
dilute
it's hot,
sulfuric acid.
don't put it back
We have
in the
it right
plastic
up here.
test tube tray.
That we have a reaction with H2SO4, and you might make sure you put 6 more somewhere in that box. And for this case, we have no reaction. And so as we look through our packet, there are a couple of different ions that also have no reaction with sulfuric acid. And so as we look at those, this is going to be for our anions, and we're going to see that acetate has no reaction, chloride has no reaction, nitrates have no reaction, and then none of the phosphates. So we're going to say that this does not react. Okay, so now we're down to the reaction with sodium hydroxide. So for sodium hydroxide, it says you will dissolve a small sample with a spatula of the unknown, 5 to 7 drops, and then add 6 molar sulfuric. So at this point, again, we're going to go back to our unknown in our vial with our spatula. If I had used any other substance besides my unknown, I'd want to make sure I was cleaning my spatula in between each use. Okay, so now I have my unknown in there. This time, if I look, I need to add 5 to 7 drops of deionized water. So, 1, 2, 3, 4. Use 5 to 4, so we'll stick with that. Okay, okay, my solution, now I've made an aqueous solution of my unknown, and at this point, I'm gonna add 1 drop of my sodium hydroxide. So here's 6 molar sodium hydroxide. I'm gonna add 1 drop. And wow, I get a red gelatinous PPT, okay? Now, notice it says, if no precipitate forms with an addition of 1 drop, do not add more. But if a precipitate does form, you may have to add many more drops of sodium hydroxide. Shake gently after each additional drop. So there's some different tests that are gonna say that they react a certain way. We can put in a couple of drops here. Nothing really happens, it's just red gelatinous PPT. So now we're gonna come up here on our reaction with sodium hydroxide, and we are going to, and I would also, folks, put here that this is 6 molar. The H2SO4 is also 6 molar. And so now I'm going to write down here that I have a dark red-brown, jelly-like PPT. Interesting. So for this particular one, I'm dealing with my cation. So look at iron and nickel and see what does it say under iron and nickel. Anything about a precipitate with sodium hydroxide?
Hydroxide reaction.
So for iron, hydroxide ions form colored precipitate, and for nickel, it says what? They also form a colored precipitate with hydroxide solutions, correct? But we don't know specifically what color that's going to be. So now what we have to do, we know that we either have iron or nickel at this point. Would you agree? Okay? We now are going to have to go and try a node. And at some point, forget this, and I will do my little try a node here, and I will say try a node, okay? And you will want to go try a node, all right? What?
Do that again.
Oh, sorry, I'll do this again. Try a node, all right? Because some of you will forget to do that. So the nodes are actually found over here, so hold me over here. So the nodes are actually over here on the counter. And I need iron and nickel in this case. You're going to leave them on the island, but I'm going to do this test over here so you can see it more easily. So now we're going to follow the exact same procedure that we did earlier today, but...
So this is where my philosophy on this lab is different. I want you to already know what those knowns look like. I want that chart filled out before I give you your known. So you're already going to know, hey, what does iron look like when you react it with sodium hydroxide? What does nickel look like when you react it with sodium hydroxide? So that's why you're going to have that body of knowledge first, then you're going to have that. Now, here's the beauty of it, is that even though you're going to have that body of knowledge, and you're going to have this unknown, and you think, oh man, what does that look like? I don't know. What you can do is you can go back and run a reaction side by side. It's like if you know you have iron, and you think you might have iron in your unknown, have 2 test tubes side by side. One where you know what iron is, and the other one where you think what iron is. React them with sodium hydroxide, whatever that reagent is, and then you can tell side by side, oh, if I know what this is iron and this is what it does, and this, my unknown, if it does the same thing, then you know it. So you have that side by side. But here's the whole point of this. This is how science is done. If you have that body of knowledge, if you already know what those knowns look like, the rest of it is gravy. That's what I want you to understand.
With our nodes. So I'm going to take another clean dry test tube, and I'm going to take 1/4 of a spatula. Add 5 to 7 drops of water. 5, so we added in our other one. And then we need to add a drop of sodium hydroxide.
So now, you're just seeing, hey,
And
what does that?
notice, what do I get? The same thing, right? So at this point, do I probably even need to try nickel? Okay, you could if you wanted to know for sure. But if we're looking color-wise, I'm going to assume that's probably not. But to be scientific about it, we should probably try it, right? And see what happens. So now, in your lab notebook, do you possibly want to write down that we know where it said it forms a colored compound? Do you want to write down what that colored compound is for iron? I'm going to do the same thing with no nickel, so I need to make an aqueous solution.
And again, observe how that, even the rate at which that dissolves, that's a key thing. Is it granular? Is
If
it
you're trying to do a
fine powder?
precipitation reaction, it's important that you get it to dissolve. If you can't get it to dissolve by just mixing it, what's one thing that we can do to help this to actually make it dissolve? Heat it up just a little bit.
Yeah, if you get
Okay, so now let's
gently
add a drop of
warm it.
sodium hydroxide. And we do get a precipitate, but is it the same color as our red precipitate for iron? No. So we now also know the precipitate color for nickel, don't we? And so you can also write
So
that down.
that's why you
in
want to
your
have that knowledge
lab.
first, so
Okay.
you don't have to do this when you have your.
Okay, so at this point, we have now confirmed that we know we have which one of these, iron or nickel? Iron. Okay, so we have confirmed that we have iron 3+. It is a red jelly like PPT. And at this point, I might need to come back and fill some of this in, but at this point, I don't have enough information that I've found to fill in the top part of my. At this point, we're going to go ahead and look at the confirmatory test on the bottom. I've already worked on one of those. Okay, so we're now down here on the confirmatory test. Well, we've already done, we know that we think we have iron, but we need to look for some other confirmatory tests. So first of all, let's work on iron since we're really close and we think we know what it is. So as I look at iron, are there any additional confirmatory tests that I could try? So we look at one, characteristic flame color, that's a confirmatory, or that's a preliminary test, we've already done that. Number 2, it's colored, we've done that. They changed the pH of a solution, that also matches up above, would you agree? And then our last one is hydroxide ions form colored precipitates with iron. I have not done that confirmatory test. So I now need to do that. Is there something else besides sodium hydroxide that we could use? So look at your reagents list on page 4. Is there a different type of hydroxide besides sodium hydroxide I could try?
Ammonium
I
hydroxide.
can try ammonium hydroxide. So at this point, I am out of clean test tubes, and so I'm going to need to wash a test tube. So to do that,
Clean test tubes
I'm
are
gonna
your
take-
friends.
a test tube brush,
Clean
I'm going to
early,
put a drop
clean often.
of Dawn dish soap on the end of my test tube. I'm going to clean my test tube.
And your last step is that you rinse that test tube with deionized water.
My last rinse is going to be with deionized water. And now I have a wet test tube. And now I need to dry it. And so to dry my test tube, very carefully, I'm going to take one paper towel, I'm going to twist it, put it down into my test tube, twist have, I should have, a clean dry test tube, okay? Looks like mine's still a little bit wet. Let's try this one more time. You'll be a pro at this by the end of the week. Thanks for zooming in. Alright, so I have a clean dry test tube. I now need to try my test with ammonium hydroxide. So if I am trying a precipitate test, I need to make an aqueous solution of my unknown. Would you agree? Okay, so I'm going to make an aqueous solution. I need a fourth of spatula of my unknown. I need to add drops of water.
And again, you want to be consistent. Always add the same amount of water, always add the same
Colored
amount of
compounds, by the way, make colored solutions, and so obviously I have a nice orangish yellow solution for my iron. And now I'm looking for ammonium hydroxide. So I found ammonium hydroxide, and I am going to see if it also forms. And notice, does it also have a red gelatinous PPT? Yes. And so at this point on my claim, I'm claiming that I have iron 3. My claim, just in all the facts that we've done, claim evidence received, my claim is that I have an iron 3 iron. My evidence is that it forms a what?
Red PPT.
Red PPT with, in this case it was a red PPT with ammonium hydroxide, so NH4OH. And my reasoning is then that I do have a confirmation. So a positive test for, in this case, iron 3. So yes, I have a positive test, iron 3. That is my reasoning. Based on the fact that here's my claim, I have a red precipitate with ammonium hydroxide. We know that matches what my book says, and so now my reasoning is I have a positive test for iron 3. Okay, so now I need to work on my anion. If I go back up and look, I have the options of acetate, nitrate, chlorine, and phosphate. So let's do some browsing in our packet again. And let's make sure that we can figure out what kind of test we could potentially run for my anions. So my anions start on page 8 in our packet. So we have acetate. It changes the pH, so that would potentially work. Oh, but look here, with sulfuric acid it effervesces. I don't know quite what that is, but did we have a reaction with dilute sulfuric acid? Did ours react with H2SO4? No. So probably not acetate. Let's look and see if something else matches better. Chloride down here. Oh, it says it does not change the pH of it, but dilute sulfuric acid does not usually react with chlorides. I know. I don't know if there's anything that totally disqualifies that, but we'll have to look and see. Phosphates would be a possibility. They do change the pH. Doesn't react. And so again, we'd have to try silver for that one, so that could be a potential one also. And then our last one is nitrates. Dilute sulfuric acid does not usually react with nitrates. They are soluble. We can conduct a brown ring test. Since we already know how to do a precipitate with silver, we're going to go ahead and try a brown ring test so I can show you how a brown ring test actually works. And so what we're going to do is we're going to follow the instructions for that brown ring test. And so as we look at that, all nitrates are soluble in water. So we're going to do the brown ring test, meaning we're not going to find anything to precipitate with the nitrate. To do this, we're going to have to start over here, and then we're going to have to move to the fume hood here in a minute when we do that. So again, I need another clean, dry test tube. So I'm going to actually use this one.
Yay!
Hold on, that's the end of that one.
Oh. There's another one?
Yeah, but the other one's really short.
Yeah, no.
Okay.
Did you write? So are you gonna say? Four-day lab instead of a.
Well, this always counts as part of it.
Yeah. Hey, at least we don't have homework. That's true.
For like the first time ever.
I know, tonight is my, 7th grade girls basketball championship. My sister, so I gotta go watch that. I was playing. It's like a really good girl that just carries the team. It's funny. And she's going to Sunrise next year. She's this one.
What?
It's like a basketball Sunrise. It's a private school. Yeah, it's like private, like Christian, like basketball. They wear skirts.
Notice I'm going to use my paper towel again. I can keep using the same paper towel multiple times. So the first thing it says that we're going to be doing on this is we're going to need a fourth of spatula of our solid unknown, and this time how many drops of water do we need on 3A? On page 9. 10. Okay, so this time we're going to need to do 10 drops of water with our fourth of spatula. Because we're going to need a fourth of spatula of our solid unknown, and this time how many drops of water do we need on 3A? Try test tube, page 9.
So this nitrate test is
10. Okay, so this time we're going to need to do 10
one that's
drops of
completely
water,
different
and
than
now
that.
I'm going to add my 10 drops of deionized water. 2, 3. Okay, so let that dissolve, we're good. Then we have to go add a fourth of a spatula of iron 2 sulfate. Crystals and left in the spatula. And so at this moment, we are going to take our 10 drops of deionized spatula and our test tube, and we're all going to go back to the fume test, or the fume hood, so that I can run the ground ring test. Okay, so let that dissolve, we're good. Then we have to go add a fourth of a spatula. So at this moment, we are going to take our spatula and our test tube, and we're all going to go back to the fume test, or the fume hood, so that I can run the ground ring test. Alright, so our next step on this is we need to add a fourth of a spatula of iron 2 sulfate, so using a clean spatula. Spatula of iron 2 sulfate. Add that to the bottom.
The main thing is, watch what happens in this reaction. Don't worry about the audio. Just watch
Right,
how
so
it
our
goes.
next step on this is that we need to add a fourth of a spatula of iron 2 sulfate. I don't have a clean spatula. I'm going to go ahead and put that and add a fourth of a spatula of iron 2 sulfate. Utility plant, and this will just stay in here, so you just need to bring your test tube back each time. So looking at this, then I'm going to put in the test tube clamp that slowly adds 16 drops of dissolved, and it does form a precipitate. This is extremely dangerous acid. I don't have a stays in hood, and then we're going to go ahead and put that in. So we're going to add 6 to 8 drops of that very slowly and let it run down the side. And this will just stay in here, so you just need to bring your test tube back each
Okay,
time.
that's just a way.
The other one's still plenty.
Yeah, the other one's so fun.
Okay, as it's slowly going down, we're starting to see that there is a brown ring that is actually forming on this. I'm going to suggest that you try this on a known nitrate before you actually try it on an unknown to make sure that you can get that brown ring. Okay? As soon as you move this, that brown ring is going to go away. So it is important that you try this and can make sure that you can get brown ring. Okay? All right, so on this particular...
No, it's on these computers.
Horrendous.
So looking at this, I'm going to put it to
It's just like, it's
This is extremely
like 15 minutes of the 39 video, just screaming at me with the camera over.
So we're going to add 6 to 8 drops of that.
Don't do that. Like, there's ones where
Look, man, I'm doing it.
she opens the door.
Okay, as it's slowly going down, we're starting to see that there is a
Okay, I do want you to watch this.
and let it run down the side. So 1, 2,
When you're doing this brown ring test,
extremely dangerous acid, so it always stays in the fume hood
yes,
and never
that
comes
stays
out.
right there. Do not
So
take
we're
that
gonna
out.
add 6 to 8 drops of that,
So
very slowly,
this is
and let it
one
run
that
down
you
the side.
want to
So
run so you know exactly what this looks like. And there's a technique to this, it's very specific. You let it run down the side.
okay, as it's slowly going down, we're starting to see that there is a brown ring that
That's
is
why it's
actually
called the
forming
brown ring
on this.
test.
I'm going to suggest that you try this on a known nitrate before you actually try it on an unknown to make sure that you can get that brown ring. Okay? As soon as you move this, that brown ring is going to go away.
That's why it has
So
to be
it
so
is
stable when you do
important
that
that
test.
you try this and can make sure that you can get a brown ring on here. Okay? All right, so on this particular case, we do have a brown ring. I know it's probably kind of hard to identify here, but you can kind of see it down here and up above on that. And so knowing we have a brown ring test, we're going to take this with us and our spatula. If we make any spills back here, make sure you put some baking soda down. And at this point, we're going to go back to the front and finish filling out our sheet. Okay, so at this point, we know that we have done iron hydroxide. We also predicted that we might have nitrate. So we have tried nitrate. And at this point with nitrate, we have used iron sulfate and concentrated H2SO4. And with that, we found a brown ring. So we have a positive brown ring for this, and so that means that we have a positive test for nitrate. So that confirms that we do have nitrate. So we have now confirmed at this point that we have iron 3 and we also have nitrate. We have to have all the preliminary tests. We also have to have at least one confirmatory test for each that was not part of our preliminary test. At this point, we're now going to go down to the bottom and we're going to record the results. You're probably going to have a lot more confirmatory tests on your first one than I did because I know what I'm doing and I can sample it. So that helps. You're going to have to do some more confirmatory tests. So you could have, let's say we would have run a silver nitrate test. So we would have taken iron dissolved in water, reacted with silver nitrate. We had no precipitate. So that would have meant that we did not have chloride in that case. So that's what we're going to use those confirmatory tests to find out. So now what I'm going to do is I'm going to roll the bottom.
Okay. Okay. So that took a lot longer than I thought it was going to happen. So here's what I would recommend for tomorrow. Okay, so here's what's going to, let me play out what's going to happen tomorrow. Tomorrow we're just going to go immediately over to the lab. You are each going to have a test tube rack, kind of like that. Okay, you will each have one of those. Every one that's going to be on the note. You're going to have 6 test tubes. Okay, and that's what you're going to work off of. You guys are going to put your test tubes in like the bottom drawer. That way no one else will mess with them. So you only really need like a test tube clamp that you're going to heat some stuff up. Otherwise, you're basically doing spatulas, you're dissolving stuff, the stuff is going to be over the, maybe a stirring rod. That's basically the only equipment you're going to need. I cannot emphasize this enough. You have to keep these test tubes clean. You're going to spend probably 1/8 of your time just cleaning glassware. But don't discount that, because here's the deal. If you don't clean out those test tubes each time and do it thoroughly, you run the next test. If you still have those residual ions from the first test into that second one, you don't know what you got because you still have those ions over them. What I would do if I were you all, okay, I would go through here and on these different tests, figure out, okay, just read through these, get an idea of what's gonna happen. How are some ions different from other ones? The other thing on here is that when you look at this, okay, here's a couple of key things. Does it form a precipitate? I would go through and I would look at your solubility rules. So ahead of time tomorrow, you already know which of these will form a precipitate with hydroxides. Okay, I would have that list. It's like maybe not on here, but somewhere I would say, okay, which one of these is going to form hydroxide? That way, in the lab tomorrow, you're not wasting time looking up solubility rules. Okay, I would read through these, figure out what's going to happen. Then tomorrow, boom, you're ready to go. The whole key of this is this. The more information that you have here, the easier your unknowns are going to be. One of the first things I would do, and you have to know what that looks like. They talked about that brown ring test. If I were you all, I'd get over there tomorrow, I'd say, okay, what do these tests look like? I would do that brown ring test. You're going to have a jar over there that says nitrate. You know that's a nitrate. Do that brown ring test so you see what that looks like. Now, a lot of these confirmation tests are actually tests by what we call negation. So for example, one of the things you do in advanced math classes is that you prove that 0 plus 1 equals 1. Okay? Doesn't seem that radical. You can't prove that 0 plus 1 equals 1. What you do is you prove it by negation. You prove that 0 plus 1 can't be anything else. And since it can't be anything else, 0 plus 1 has to equal 1. So that can actually be a confirmatory test. It's a proof by negation. If you say, hey, I'd run this test and it doesn't form a precipitate with silver ions, I know it can't be All right? So the more time you spend between now and tomorrow reading through this, getting an idea of what's going to happen, the more efficient you're